Section 312.5b of the National Electrical Code, or NEC, addresses specific requirements for using knockouts in electrical enclosures. This section mandates that when an enclosure is equipped with knockouts, each conduit or cable must enter the enclosure through a separate knockout. Furthermore, if an individual knockout is utilized, it is essential to equip it with a cable connector. This requirement extends to metallic conduit, metal-clad cable, and non-metallic raceways that have metal armor or contain other conductors. These must be securely fastened to the enclosure. The interpretation of this code section clarifies that each individual knockout located on the top of the panel must be used for a separate wire or cable. Every knockout needs to be fitted with a cable connector, such as a Romex connector or a bushing. The primary reason for this requirement is to prevent wires from chafing against the enclosure and to maintain the overall integrity of the enclosure. Using a plastic bushing in the top of the panel does not meet the requirements because it is not considered an acceptable cable connector as defined by the NEC. Consequently, an inspector is correct in citing a violation of Section 312.5b if a plastic bushing is used in this manner. In addition to utilizing individual knockouts with Romex connectors, it is also necessary to staple each wire within 12 inches of the top of the panel. This is a standard requirement for securing cables within enclosures, as outlined in Section 312.6 of the NEC. It's crucial to adhere to the NEC requirements to guarantee the safety and reliability of all electrical installations. The NEC guidelines are designed to minimize risks associated with electrical systems, including potential fire hazards, electrical shocks, and equipment failures. By using the correct cable connectors and ensuring that all wires are properly secured, you can help prevent these dangers and create a safer environment. Therefore, it's vital to understand and follow the specific requirements outlined in Sections 312.5b and 312.6 of the NEC to maintain compliance and promote electrical safety. Firstly, consider the selection of appropriate cable connectors. The NEC mandates the use of cable connectors that are specifically designed for the type of cable or conduit being used. Romex connectors are commonly used for non-metallic sheath cables, while other types of connectors are available for metallic conduits and armored cables. It's essential to choose a connector that provides a secure and reliable connection to the enclosure, preventing the cable from being pulled out or damaged. Secondly, ensure that each individual knockout is properly utilized. Avoid the temptation to run multiple cables through a single knockout, as this can lead to overcrowding and potential damage to the cables. Instead, use a separate knockout for each cable or conduit and install a cable connector at each knockout to provide a secure and strain relief connection. Thirdly, pay attention to the requirement for securing wires within 12 inches of the top of the panel. This requirement is designed to prevent the weight of the cables from putting undue stress on the connections at the top of the panel. By stapling the wires within 12 inches, you can distribute the weight of the cables and reduce the risk of damage to the connections. Moreover, proper wire management is essential for maintaining a safe and organized electrical system. Keep wires neatly bundled and secured to prevent them from becoming tangled or damaged. Use cable ties or other appropriate fasteners to keep wires in place and prevent them from rubbing against sharp edges or other components. Additionally, it is crucial to follow all other applicable requirements of the NEC, including those related to grounding, bonding, and overcurrent protection. These requirements are designed to provide a comprehensive system of protection against electrical hazards, and it's essential to adhere to them strictly to ensure the safety of people and property. Furthermore, regular inspections and maintenance are essential for maintaining the safety and reliability of electrical systems. Inspect all connections and components regularly to ensure that they are in good condition and properly secured. Replace any damaged or worn components promptly to prevent potential hazards. In summary, compliance with Section 312.5b of the NEC is essential for ensuring the safety and reliability of electrical installations. By using the correct cable connectors, utilizing individual knockouts properly, and securing wires within 12 inches of the top of the panel, you can help prevent electrical hazards and create a safer environment. Always consult the NEC and local electrical codes for specific requirements and guidance, and seek the assistance of a qualified electrician if you have any questions or concerns. Following these guidelines will not only ensure compliance with the NEC but also promote the overall safety and reliability of electrical systems. Remember, electrical safety is a shared responsibility, and it's up to everyone involved in the design, installation, and maintenance of electrical systems to take the necessary precautions to prevent accidents and injuries. The importance of proper grounding and bonding cannot be overstated. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Bonding connects all metal parts of the electrical system together, ensuring that they are at the same electrical potential, which also helps to prevent electrical shock. It is also crucial to use the correct size of wire for the circuit. The NEC specifies the minimum wire size for different ampacities, and it is essential to follow these requirements to prevent overheating and potential fire hazards. Overcurrent protection devices such as circuit breakers and fuses are designed to protect the wiring from overload and short circuits. It is essential to use the correct size of overcurrent protection device for the circuit to ensure that it will trip in the event of a fault. Proper labeling of electrical panels and circuits is also essential for safety. Each circuit breaker or fuse should be clearly labeled to indicate the circuits that it protects. This will help to prevent confusion and ensure that the correct circuit is energized when performing maintenance or repairs. Additionally, it is essential to follow all applicable safety procedures when working with electricity. Always de-energize the circuit before working on it, and use appropriate personal protective equipment such as gloves and eye protection. Never work on electrical systems when you are wet or tired. Always follow the manufacturer's instructions when installing or using electrical equipment. Finally, it's essential to stay up to date on the latest electrical codes and standards. The NEC is updated every 3 years, and it's important to be aware of the changes to ensure that your electrical installations are in compliance. Attending training courses and seminars can help you stay informed about the latest developments in electrical safety. In conclusion, electrical safety is a critical concern, and it's essential to follow all applicable codes and standards to protect people and property from electrical hazards. By understanding and adhering to the requirements of the NEC, you can help to create a safer environment and prevent accidents and injuries. Always prioritize safety when working with electricity, and seek the assistance of a qualified electrician if you have any questions or concerns. The requirements of Section 312.5b and 312.6 are specifically designed to address the risks associated with wire chafing and insufficient support, which can lead to insulation damage, short circuits, and potentially fires. When wires are not properly secured and supported within an enclosure, they can move and rub against the sharp edges of the knockout holes. Over time, this chafing can wear away the insulation, exposing the bare conductors and creating a pathway for electrical current to flow where it shouldn't. This can result in a short circuit, which can trip a circuit breaker or fuse, causing a power outage. In more severe cases, a short circuit can generate enough heat to ignite nearby combustible materials, leading to a fire. By requiring the use of cable connectors at each knockout and the stapling of wires within 12 inches of the top of the panel, the NEC aims to prevent this chafing and ensure that the wires are adequately supported. Cable connectors provide a smooth, rounded surface for the wires to pass through, reducing the risk of abrasion. Stapling the wires helps to distribute the weight of the cables and prevent them from sagging or pulling on the connections. Additionally, the NEC specifies the types of cable connectors that are acceptable for use in different applications. For example, Romex connectors are designed for use with non-metallic sheath cables, while other types of connectors are available for metallic conduits and armored cables. It's essential to choose the correct type of connector for the cable being used to ensure a secure and reliable connection. The NEC also provides detailed requirements for the installation of cable connectors, including the proper tightening torque and the use of lock nuts and bushings. Following these requirements is crucial for ensuring that the connectors are properly installed and will provide adequate protection against wire chafing. In addition to the requirements of Section 312.5b and 312.6a, the NEC also includes other provisions related to wire management and support. For example, Section 300.4d requires that cables passing through holes in framing members be protected from abrasion by bushings or grommets. This requirement is designed to prevent the cables from being damaged by the sharp edges of the holes. Section 334.30 specifies the requirements for securing and supporting non-metallic sheath cables. This section requires that cables be supported at intervals not exceeding 4½ feet and within 12 inches of boxes, cabinets, and fittings. The NEC also includes requirements for the use of cable ties and other fasteners to keep wires neatly bundled and secured. These requirements are designed to prevent the wires from becoming tangled or damaged and to ensure that they are properly supported. By following all of these requirements, you can help to prevent wire chafing and ensure that your electrical installations are safe and reliable. Remember, electrical safety is a shared responsibility, and it's up to everyone involved in the design, installation, and maintenance of electrical systems to take the necessary precautions to prevent accidents and injuries. Always consult the NEC and local electrical codes for specific requirements and guidance, and seek the assistance of a qualified electrician if you have any questions or concerns. Proper wire management and support are essential for maintaining a safe and reliable electrical system. Neglecting these aspects can lead to a variety of problems, including wire chafing, insulation damage, short circuits, and even fires. In addition to the specific requirements outlined in the NEC, there are also some general best practices that can help to improve wire management and support. One important best practice is to plan the layout of the wiring system carefully before starting the installation. This will help to minimize the amount of wire needed and to ensure that the wires are routed in a way that is both efficient and safe. Another best practice is to use a variety of wire management tools and accessories such as cable ties, clamps, and supports. These tools can help to keep the wires neatly bundled and secured, preventing them from becoming tangled or damaged. It's also important to choose the right type of wire for the application. Different types of wire have different insulation properties and are designed for different environments. Using the wrong type of wire can lead to premature failure and increase the risk of electrical hazards. For example, THHN wire is a common type of wire used in residential and commercial wiring systems. It has a thermoplastic high heat resistant nylon coating that provides excellent protection against moisture and abrasion. However, THHN wire is not suitable for direct burial in the ground. For direct burial applications, UF wire should be used. UF wire has a solid plastic insulation that provides excellent protection against moisture and corrosion. It's also important to consider the ampacity of the wire. The ampacity is the maximum amount of current that the wire can safely carry. Using a wire with too low of an ampacity can lead to overheating and potential fire hazards. The NEC provides tables that list the ampacities of different types of wire. It's essential to consult these tables to ensure that the wire being used has an adequate ampacity for the circuit. In addition to choosing the right type and size of wire, it's also important to install the wire properly. Wire should be properly terminated at all connections, and connections should be made using approved methods and materials. Loose or corroded connections can lead to overheating and potential fire hazards. Wires should also be protected from physical damage. Wires that are exposed to physical damage should be protected by conduit or other protective measures. It's also important to avoid running wires in areas where they are likely to be exposed to moisture or chemicals. Finally, it's essential to inspect the wiring system regularly. Wiring systems should be inspected for signs of damage or deterioration. Any damaged or deteriorated wiring should be replaced promptly. Regular inspections can help to identify potential problems before they become serious hazards. By following these best practices, you can help to ensure that your electrical wiring system is safe, reliable, and efficient. Remember, electrical safety is a shared responsibility, and it's up to everyone involved in the design, installation, and maintenance of electrical systems to take the necessary precautions to prevent accidents and injuries. Always consult the NEC and local electrical codes for specific requirements and guidance, and seek the assistance of a qualified electrician if you have any questions or concerns.